Greetings, fellow knowledge seekers. Welcome to Paper Ledge, where we transform dense academic papers into digestible audio experiences. Today, we are going to dive into a fascinating paper titled SSL4RL, Revisiting Self-Supervised Learning as Intrinsic Reward for Visual Language Reasoning. It explores how we can make AI models better at understanding what they see, not just what they read. Have you ever wondered how AI models learn to see the world? I mean, really, see it, instead of just relying on text? That's the core question this paper tackles. Imagine our minds are like vast cosmic cities. Each street represents a different piece of knowledge. Now, some streets are well lit, lined with glowing neon signs. Those are the things AI knows well from language, but the visual streets? Often, they are dimly lit, barely explored. This paper, SSL, provides a new framework to illuminate those darker corners of AI's visual understanding. It is like giving our AI models a pair of cosmic glasses. So, what's the big idea? The key is self-supervised learning. SSL is all about teaching AI through puzzles. It's about tweaking data in a way that creates intrinsic verifiable targets. Imagine an image, Ernis. 1. Rotate it slightly. 2. Ask the model to figure out the angle. 3. Booyah! It is a self-generated quiz with a right answer. The paper introduces SSL4R, which is basically this self-supervised learning, but supercharged with reinforcement learning. RL. Alright, let's stroll down the main boulevard of this framework, shall we? First, we have the corruption function. Think of this as our mischievous cosmic gremlin. It takes an input, like an image, and messes with it. It might rotate it, scramble its pieces like a jigsaw puzzle, or hide parts of it. This creates a challenge, a trajectory, as the paper calls it. We are messing with the data, and turning this into an intrinsic verifiable target. Second, the policy. The AI model looks at this corrupted image. It tries to predict what the original, unmessed with image was. This is where the AI uses its smarts, its policy, to navigate the cosmic city and figure out the right answer. Third, the reward. This is the cosmic pat on the back. If the AI guesses right, it gets a reward. If it guesses wrong, well, it learns what not to do next time. This is the reinforcement learning part, guiding the AI to make better choices. So, we have a mischievous gremlin, a brainy model, and a cosmic reward system. Put them together, and you've got SSL4R. Now, you might be wondering, Ernie, how does this actually work? Well, the researchers tested SSL using 4 different self-supervised tasks. Let's picture this as 4 rooms in our memory palace. 1. Rotation prediction. Imagine a picture spinning like a cosmic dancer. The AI has to guess how many degrees it's turned. Easy peasy. 2. Jigsaw puzzles. Now, picture an image shattered into pieces. The AI has to put it back together. This helps it understand spatial relationships. 3. Contrastive learning. Imagine 2 slightly different versions of the same image. The AI has to figure out if they are from the same source. 4. Patch position prediction. Now, picture a zoomed-in piece of an image. The AI has to guess where that piece belongs in the bigger picture. Fine, yeah, I guess. The point is, this paper is a big deal. But here's where things get really interesting, my friends. The researchers found that not all SSL tasks are created equal. It is like some streets in our cosmic city are more helpful to explore than others. Some tasks, like rotation and patch position, worked wonders, improving the AI's visual reasoning skills significantly. But others, like contrastive learning, sometimes, well, they didn't help as much. In fact, in some cases, they even hurt performance. Why? The answer, it turns out, lies in the difficulty of the task. It is like giving a toddler a calculus problem. Not helpful. The researchers discovered that the SSL task needs to be challenging enough to push the AI, but not so difficult that it becomes completely lost. And here's a little surprise. Model size matters. What works for a smaller AI might not work for a larger one. It is like giving a child a puzzle that is too easy. They get bored. The researchers found that larger AI models need more complex SSL tasks to truly benefit. But wait, there's more. The researchers also tried combining multiple SSL tasks. You would think that more is always better, right? Wrong. Turns out, just throwing everything at the AI at once can be confusing. It is like trying to explore too many streets in our cosmic city at the same time. You get lost. The researchers found that combining SSL Tasks requires a more sophisticated approach, like carefully balancing the rewards or scheduling the tasks in a specific order. Now, to top it off, the researchers even showed that SSL4RL isn't just for vision language models. It can also be applied to graph learning, where AI models learn from relationships between objects. It is like expanding our cosmic city to include whole new galaxies of knowledge. So, what's the takeaway from all of this? SSL4RL offers a powerful new way to improve AI's visual understanding by repurposing self-supervised learning tasks as intrinsic rewards. By carefully choosing the right tasks, balancing their difficulty, and considering the model size, we can unlock the full potential of self-supervision. And what about the future, you ask? Well, this paper opens up a whole new avenue for research. Imagine developing even more sophisticated SSL tasks tailored to specific AI models and applications. Imagine creating AI that can truly see and understand the world around us, not just read about it. That's the promise of SSL4, and that's why this paper is such a cosmic gem. So, keep exploring, keep questioning, and keep pushing the boundaries of knowledge. Until next time, this is Ernis, signing off from Paper Ledge. Go forth and illuminate those dimly lit corners of the AI cosmos.